Okay. Third time's a charm, people. We got there. Oh, goodness. Alright, so starting everything again. For those of you who are watching this at home after the fact, or for anyone who's going to be joining us in a moment, if you haven't already seen week 12's review session, go ahead and watch that before you watch this one. In week 12, we went through an overview of the course content, we worked through a past exam paper, and we also went over the structure of what the exam is going to look like. I'm going to touch on that briefly again now, but please go back and watch that because I'd prefer to focus on general review stuff during this session. Had a bit of a question while we were having some AV issues just before about what, how to approach some of the FRP stuff in your revision and in preparing for the exam. So the first thing there was, so the question was in terms of, okay, well, sodium versus Kafka code, and the answer to that question was, I don't expect you to write that type of code in an exam. So the purpose of us looking at the sodium implementation and looking at Kafka and actually implementing in Kafka was to implement the theory. But in the exam, you're going to be assessed more on the theory itself. So make sure you're familiar with the conceptual view of a FRP system, that is like the flowchart style diagram, and also the timeline view of one of those systems, or also known as a marble diagram. If you can read and understand conceptual and timeline views of FRP systems, then that will be beneficial to you in the exam, and that's what you want to focus on. That's one of the things that you want to focus on in your review. I think that's probably also a good place to lead into actually stuff to go over in this session. So let's pull up week 11's workshop while we're on the topic. Does anyone have anything else that they'd like to specifically cover in this session while I'm pulling that up? Okay. All right, so we have week 11's workshop here, and you can see two questions. One, working with a timeline view of an FRP system. One, looking at a conceptual view of an FRP system. Now, in the case of this one here, in the case of this one here, this one comes straight out of, both of these come straight out of the book, so I'm sure you'll be able to actually find these examples in the book. But that's the kind of format of question that we're going to be looking for when it comes to FRP stuff. So make sure you can answer all of these questions, I think is a good approach to take to that section of the exam. Let's take a look at the first question here. So the question is, consider the timeline view of an FRP primitive below. Here's the timeline view. And asks us to recognize what primitive this is and to describe the general behavior of the primitive. Now, hopefully it's reasonably obvious, but it might take a little bit of looking at the diagram to get used to. Partly because like the diagram itself, this type of diagram, a timeline diagram, inherently describes the behavior of the system by explicitly showing you the inputs and the outputs. That's why we use this type of diagram. So let's take a look at this diagram and see if we can sort of infer what's going on here. So we have three streams. We're not really told which one is which, but usually the streams at the top are going to represent your inputs, and the streams at the bottom are going to represent intermediate or output streams. So if you can find some sort of way to relate the streams to each other, that will give you an inference of how the system is actually, what the system is actually doing. So let's take a look here. Let's take a look here. Okay, so stream one, At time 0, we have a value of 0 in stream 1, and then at time 2, we have a value of 2 at stream 1, and there's nothing happening at the other times. Stream 2, we have nothing on time 0, and then a value of 10 at time 1, 20 at time 2, 30 at time 3, and nothing at time 4. And then we have stream 3, which, as you can see, 0, 10, 22, 30 at the respective times. What can we guess about this system based on what we're seeing here? Can we see a relationship between these streams?
The sum of the other two streams.
Yes, the sum of the other two streams. What primitive does this represent?
Merge.
Yeah, it's the merge primitive. So it's taking two streams and merging them together. So you have stream 1, which is an input stream, stream 2, which is another input stream, and stream 3, which is the result of combining those two streams. When we look at that in the conceptual view, you can see that it shows us like a merge operation down here in the conceptual view. You can see that it appears as like two inputs and one output. But realistically, in an FRP system, as you can see here in the timeline view, it's not like stream 1 and stream 2 terminate as a result of their values going into stream 3. What we have is we have stream 1 and stream 2 and then a new stream, but I could key into any of these three streams if I wanted to do things with the values that they provide, which is nice. So yeah, that's timeline view. Let's take a look at the second question here. Consider the conceptual view for a spinner button, and it asks us about the snapshot primitive and what the role of the snapshot primitive is. So going back through our functional reactive programming book and taking a look at the descriptions of each of the different primitives, making sure we're familiar with what they all do, how they relate. So you could get a question like this in the exam. You could get a question here that doesn't tell you what the system actually does, but maybe says, okay, well, tell me what this system is doing specifically related to, you know, this snapshot operation here. What does this snapshot operation do in relation to the rest of this system? Or what does this system do as a whole? I see some thoughts and questioning, maybe. Let's just take a moment and go through what this system as a whole does,
Set and hold.
Conceptually. Sorry, set and hold, what? Well, the snapshot and the hold.
Doesn't the snapshot convert a string into a cell? Like it saves the current value as a state in the system.
So a snapshot, I'm blanking here. A snapshot takes a cell and a stream and does something with the values from those two, and then outputs a stream, if I'm remembering off the top of my head correctly here. So then we have this filter operation which goes into a hold operation, I think. So the filter out. So because we have the snapshot here, we have a stream going out into a filter operation, then the filter operation is getting pushed to a cell, and then that value is getting held in the cell with a hold operation, with a cell hold operation. That's what this is there.
It takes a cell and converts it into a stream.
So it takes a stream in and a cell in, and it combines those values in some way. So it's kind of like a merge, but you have, instead of two streams, you have a cell and a stream. So it's a way of taking a value that might change over time and interacting with that value whenever we receive data or an event through a stream. So in this case, what we have is we have these two map operations to start with. So it's a really interesting way of like representing a system like this. It's probably a little bit overly complicated, considering the way that we normally tend to program these things. But basically, to start off with, we have two buttons. They emit an event whenever they're clicked, just a straight up click event. So we have these map operations that we pass these events through. Every time a click event is received, it gets passed through a map operation and gets mapped to a value, in this case the value 1. And a value 1 for the plus button, the value -1 for the minus button. And then those two streams get merged together. So instead of having click events, now what you have is +1s and -1s, a stream of +1s and -1s. And they go into the snapshot. The snapshot says, this is the current value of my spinner. We know what a spinner button is, yeah? Very quick reminder, a spinner is like one of those number inputs where you have an up-down button next to it, and you press the up button, the number goes up by 1. You press the down button, the number goes down by 1. So in this case, the cell holds the value of like what is in that spinner button, whether it's 5 or 6 or something, and when you press the plus button, I get a 1 value coming into the system. That gets added to my 5 or 6, and then that new value is getting held in the system. In addition, this one has a filter that's like, oh, let's make sure we can't go below 0. So the filter operation, if we keep pressing the down button or the minus button, when the value that results from the snapshot goes negative, the filter operation just removes it from the stream altogether. So the event terminates at that point in time, and we no longer update the button. Yeah, that's what's happening in that system. So hopefully that makes some sense. Try to get roughly familiar with reading these diagrams. I'm not going to make it a super complicated diagram that you get put through in an exam, but try to familiarize yourselves with all the basic operations. Now, I know I said that you're not going to be writing FRP code in the exam. That was more just for your general practice and theory as part of this particular workshop questions. It might help you to write some basic FRP programs just to make sure that you're understanding how those systems work. But I'm not going to ask you to write FRP code in your exam. Do make sure you're familiar with the concept of the unified log. Hopefully the work that you've done with Kafka in this past assignment has meant that you're familiar with at least some parts of the unified log. Hopefully you're familiar with the ways that it can be used to look at data values over time through some of the parts of the assignment that you've done, but make sure you're familiar with that. Have a read of the sections in the event stream processing book that touch on the fundamentals of the unified log so that you understand the theory behind it, even if we didn't get to use all of that theory in the prac, but hopefully we got to use like a reasonable chunk of that theory in the prac. And obviously question 5 was for you to help you with your prac. Okay.
What's the question 3 program means? It now means the code, flowchart.
So question 3 would be the code. That's the coding question. And that would be writing a program using the programming language that we looked at in the functional reactive programming book, which was not Kafka. But as we've seen, hopefully as we've seen, the concepts will translate across between the operations that we were doing in functional reactive programming and the stuff that we were doing with Sodium. I'm hoping that you all saw how that translated across to Kafka, that even though the code itself was different, the fundamental operations were similar or the same, albeit maybe some of them had some different names than the ones in Sodium, but hopefully you should have found many of those many of those primitive operations existing in Kafka when you implemented your Kafka code. Okay. Other questions? Yes?
Just kind of a general question about the merge primitive.
Uh-huh.
So in the second diagram, the merge is just aggregating the ones and negative ones into
Yep.
a single stream.
Yes.
But then in the diagram above, it's adding them together. Only if they are at the same time.
Yes. Yes and yes. Yes and yes. So the question for anyone watching at home was, in the bottom diagram, the merge primitive just combines the two streams. It like zippers the two streams together. So if you get a 1, the stream has a 1. If you get a -1, the stream has a -1. In the top one, we see that it's effectively adding the two streams together. It's worth words. And we were a little unsure about how they relate to each other in that way. And the answer was, okay, well, in this case, it is taking the top value from the top stream when just that value occurs. It takes the bottom value from the bottom stream when just that value occurs. But when you have two events that occur simultaneously, at least in sodium FRP, it gives you a way to, there are a couple different options. There is one version of the merge operation. They actually have two separate versions of the merge operation in sodium. There's one that says, okay, I will take one of these values from one of the streams, and you get to effectively specify which stream is the one that takes priority over all the others. The other option is when you have two streams that you can specify some functionality that runs to determine what the outcome will be. In this case, in the case of the top example, the outcome is that we literally added the two numbers together. But if you wanted to, you could do something like, oh, get me the greater of these two numbers and only send the larger value through. So like a kind of a filter, effectively. But in the actual code implementation, you had the opportunity to write the function that controlled what the output value was when you got two events simultaneously on the two streams. Yeah.
Yep, so sort of in a general case, the merge primitive can also be a merge and apply a function.
Yeah, it can effectively be like a combined merge and map versus just a straight up merge. And I think in Kafka that has a slightly different name. They're actually like two explicitly different functions. I think, is it flat map? No, it's not flat map. I mean, it has a different name in Sodium as well. I think it's called, if I'm blanking on what it's called, so many different function names. I think it's, is it like once or something? No, it's not once. Anyone who has the book handy, feel free to take a quick look at which function is which. But yeah, there are two separate versions of the function in Sodium, and I think Kafka also has different versions for the different purposes. But for the sake of like a primitive, we consider it a single primitive model because its primary job is to take two streams and combine them together. Yeah. Good question. All right. I think that's a good moment. Well, other questions or in general questions, things that we want to focus on for the rest of the session? Legion, do you have any questions you want to ask? That's okay, let's just do a very quick recap of exam itself. Okay. Again, hopefully this should look familiar for those of you who watched week 12's. Here is an example of what the exam looks like. Some of you have done paper-based exams before because you remember the before times. Some of you just started a master's degree this year or last year and you're like, what the heck, how do exams even run? Never seen one of these things before. So this year's exam, for everybody, this year's exam might look a little bit different than some of the exams you've done in the past. So a very quick recap. If you're sitting the paper-based exam, this is what it will look like. Obviously not this example because it's an example one, but this is the same template that the exam for this course runs off of. This exam is written as a write your answers on the actual question booklet exam, as opposed to some of the other exams you might be familiar with where you're given a separate booklet that might be blue or pink that you actually has lined paper that you write your answers in. So you'll find that on every page there are spaces for you to write all of your answers. Use this to your advantage. I have put what I think is a reasonable amount of space for you to write your answers in for each of these questions. So if you're finding that you need half a page to like write the answer to what you think like this question is, you're probably putting a lot more detail in than you need to. The other way to keep to get an idea of how much time and effort you should be putting into a question is the amount of marks that are associated with the question. I know I said at the start of this course that all marks in this course would be directly proportional to each other. You may or may not remember that. So what I meant by that was you will have noticed that, for example, your marks for assignments, they're out of 200 and they're worth 20%. Those marks are all directly proportional. Each mark that you get in the assignment is worth 0.1% of your final grade. I was originally going to set this as out of 400 marks. However, one thing that we have done in the past is that we, for timed exams, tend to make the number of marks directly proportional to the number of minutes in the exam. So the exam's out of 120 and it takes 120 minutes to do. So in theory, it should roughly take you 5 minutes to answer this question, or it should not take you more than 5 minutes to answer this question. So if you find that you've spent 7 minutes on this question, you've probably spent too long on the question. You're probably doing it in more detail than you need to. Now that doesn't necessarily mean if you don't know how to answer the question, you're taking a really long time to answer it because you don't fully understand what the question is asking, or you're not quite sure how to answer it. It might take you a bit longer, but if you're across the content and you understand the question, this question here in particular should not take more than 5 minutes to answer. So between the amount of space that's left for you to actually write out your answer to the question and the amount of time or the amount of marks that are associated with the question, hopefully that will give you a good guide to keep you on track for how long throughout the exam and the amount of time it takes you to do things. So obviously a bigger question will have a bigger space associated with it for you to answer. You're not going to have a single question that's worth 105 marks, but just as an example, and also because I actually, in order to make this show up, I had to make the total number of marks in this example total to 200. So multiple choice questions, you'll have spaces to color in. You can put a cross in the box, or you can color the box in. Just make sure that the box with your answer is clearly marked.
Do we have to correct the box?
If you have to correct the box, that is a good question. The way that I would do that is, if I needed to make a correction, I would put a line through like this, and then I would tick the correct answer and like maybe circle it or something, or like write on the paper. I was unsure. We'll go back and check these, but and try to pay special attention to any questions where there are like lines and things through. If you find that your answer does end up taking up more space, or you need to rewrite an answer, at the end of the paper there is extra space for answers. Make sure that when you use the extra space for answers that you write the question next to the answer. So this would be an answer for 2A, and then also make sure that in the corresponding question you make a note for us to look at the extra pages, because if we don't know that more of your answer is in the extra pages, we're just going to assume that that's like it, and like we'll check them at the end, but we might miss them. So please help us not miss things. Otherwise you might be all like, oh no, I failed the course, and then it's just like, no, maybe you didn't fail the course, but we missed a section of your answers because you didn't tell us that your answers were going to be there. So and then it's, it creates this whole back and forth, and just make it easier for yourself and for us and for everybody, and that's that. Also, please write your student number at the top of every page. There's a space for it for a reason, and that's because to make the marking easier, once we get all these back, we're going to break the staples off of them and scan them in. This means also that we will have an electronic copy of all of your exams, which means that you will be able to review your exam answers and marks electronically, as opposed to having to arrange a face-to-face viewing session if you want to review your answers and the marks that you got. But that also means that if you haven't written your student number on every page, if for whatever horrendous reason, and I don't foresee this happening, but if for any reason your exam gets separated as in the pages get mixed up or separated from each other, if your student ID is not on them, we may not be able to group your answer back together, and that's going to result in you not being able to get the marks, or it's going to create a lot of problems if that happens. Please write your answer on your student number on every page. I don't anticipate this being a problem, but that's why. That's what's going on there.
Will we have reading time?
No, you will not have reading time this semester. Yes, I know reading time has been a thing in the past. They removed it partly because they couldn't do reading. I think partly because they couldn't do reading time with the proctored online exams. So they've just removed the reading time across the board.
They removed it before the proctor, because
They did they?
removed it I think first semester this year or earlier last year, because I remember.
But
hearing
that's a COVID thing.
The
Yeah.
online lecturers complaining about it, saying the policy, the university just removed reading time because something to do with the timing of online exams or something, or at least that was their excuse when they told my lecturer. So then
Yeah, I mean that's my understanding as well. It's to do with the online and the proctoring exams. Basically, they can't do reading time in those exams, so they just removed it across the board to try to make it fair across the board.
Yeah.
I would like to see reading time brought back, and I think it certainly seems that the university is aiming to go back to 100% face-to-face, probably, if not first semester next year, end of second semester next year, which means we won't necessarily have online proctored exams, which means that hopefully we'll be able to have reading time again. Or at least, if people can't reasonably get back into the country, then we'll keep doing the online thing, but not that that'll affect any of you. You'll all be out of here by then. Presumably you'll all be out of here by then, hopefully.
So just double check,
Mhm.
the answer is only allowed to put in the box.
Yes, if you write the answer outside of the box, then it won't be picked up when we scan it in. Like it'll be picked up. It'll exist in the soft copy of the exam, but when question 1 is presented to the marker to mark your question 1 answer, the marker will only be presented with the contents of the box. They will not be presented with what is outside the box. So,
Except for extra pages, that will be given in full.
well, I mean, if you write "see extra pages" in your question, then the marker will know to explicitly go through and find the extra pages and search those. And realistically, once we've done all of the marking, we'll probably go through and do a sweep of all the extra pages just to pick up anyone who has answered in the extra pages and make sure that that's added to the marks if needed. But yeah, the person marking the exam will only see this space when they get given question 2 to mark. So
if we do say like a short answer question, and we kind of, I guess we realize we explained it wrong or something, would we just cross it out and immediately go see extra pages if we can't fill out our new answer within the box?
yeah, absolutely, yeah. So yes, if you make a mistake on an answer and you think there isn't enough space, or there isn't enough space for you to write the correct answer in the space provided, so if this is my answer, this is my answer here, what I would do is, the first thing I would do is I would put a big, I'm going to do this in red, but don't actually do this in red, but for the sake of illustration, I would put a big line through it like that. Don't scribble the answer out. Don't attempt to block us from being able to view the answer, because if you were to write a mostly correct answer, then cross it out and run out of time, if you had blacked out the answer so that we can't see what you've written, then you're not getting any marks. But if you've crossed out your answer and then you don't have time, or you write something that is just completely wrong on the extra pages, we'll be able to see that you had your original answer. You'll get some of the marks at least. Yeah. For the people doing the online exam, it's a MyUni quiz. Everything's done through. It'll show up as a MyUni quiz. For the questions where you have to I'll do this quickly. I'll try to do this quickly because I have already said this a little bit. The multiple choice questions will be an actual multiple choice online question. Short answer questions where you write text will be a text box that you can fill in the answer, same as you would with a regular MyUni quiz. If you come across a question where you need to draw a diagram, you'll be told, draw this on paper. So make sure that you have blank paper with you in the exam, and you draw it on paper. After the exam is finished, you'll have a chance to take a photo and upload it. But complete everything first, and then after the exam is finished, you can take your time, photograph your stuff, and upload it. You'll have extra time to upload stuff after the exam is finished. Yep, that's that. Watch the other lecture if you're unclear, or ask questions on Piazza if you're unclear. All right.
About the multiple choice
Uh-huh.
questions, is it one answer only or one?
The question will tell you.
Oh,
The question will explicitly say, fill in one answer only, or it will say, choose as many as are correct. And if the question doesn't explicitly say that, someone has messed up writing the question. But I can tell you that the question does say that. Yeah. Look, I suppose, look, if the question isn't clear, assume that you should just fill in as many as are correct. And if it just happens that that's only one answer, then that's great. If it's multiple answers, that's good. But the question says it. The question does say it. Yep. Okay. Other questions? Do we want to look at some past exam papers that we haven't already covered in week 12? Do we have particular concepts that we want to focus on a little bit more? Legion, do you have any questions?
But what she saw, the quality is not very clear.
Sorry?
yeah, she's telling me that what she saw is not very clear.
Oh, okay. I thought I said it's a high def. Is this just on like
Oh yeah.
on WeChat or something, or is this
On
because like
WeChat.
I don't see the questions showing up in here?
Yeah, on WeChat she sent me a screenshot.
Oh, okay.
Yeah, it's pretty, as you see.
I mean that's a
You know, put them in the document camera.
oh, okay.
So basically information.
Fair enough. Hang on, let me just.
Chuck something on the document camera. You can have a live view, or whatever the delay is on this.
That's a few second delay.
That's not bad.
I think it might scale depending on people's internet connections. I'll zoom this in a little bit. Oop, wait, no, this is an old exam. But hopefully you'll get the idea. Gonna leave that there for a second. All right, looking at a past exam, we don't have a lot of time left, so are there any particular questions or topic areas from whichever past exam? Not 2019, because we looked at that already, but what do you reckon, 2017 or 2016? Fun fact, 2016 you don't have a copy of, so 2017 or 2016?
16.
16, okay. What topic do we want to look at? Like we don't have time to, or at least I mean, I suppose I can just keep going. But so here is 2016's exam, and going through we have. I'll zoom back out for a second just so we can. Okay, so we have a section on FSAs. We have More FSA stuff focusing on NFAs. We have merely more. This was a we have a reflective question on the assignment that you all did. You're not going to get this question in the exam, so we're going to skip that. Design patterns. We didn't do design patterns in this course. And we didn't do Fitts law in this course. Petri nets. We also have a question on Petri nets.
No synchronicity or anything?
Well, this particular exam doesn't have a synchronization question on it. Which question, if any, do we want to actually do?
Million more will be
Okay, yeah.
Yeah,
will be in the design question.
Million more will be in the exam, yes.
I'll put a voting for a million more because it was like the chunkiest question.
It probably is the chunkiest question. It's the one you'll probably need to spend the most time on, yeah, absolutely. Well, arguably. It is a chunky question, yeah.
Unless you make us draw like a Petri net.
Maybe. I mean, you saw that this exam has both.
Yeah, but that's a fairly small Petri net compared to
I mean, it's worth noting with this one that you have the Petri net already drawn for you. I wouldn't make you design a Petri net from scratch and design a merely more system from scratch. So, all right, let's take a look. See here. You've been asked to design the software for a car locking system's 2-button remote control. The remote has a red light that lights up when either button is pressed. There is a source of timing signals that ticks 10 times per second. There are 2 buttons on the remote labeled unlock and lock. You may assume that the car's lock starts in the locked position. When the user presses the unlock button, the red LED will blink twice and the driver's door only will unlock. If the unlock button is pressed again before 10 seconds... Did we do this question in tutorials?
or I'm not sure.
Yeah,
A bit of both.
a bit of both.
I think it was the garage door.
It was the garage door.
But it had the ticker and the buttons.
I imagine that the garage door didn't have the, like, a lock and unlock kind of...
Oh, it might not have been the garage door. It might have been the
Maybe it was this actual one that we did at some point in one of the questions. Let's take a look at it again. I don't think that we actually did this in lectures.
We definitely had one with a ticker and...
This might have been one that we did in a workshop.
Oh.
We can always check the workshop. This would have been workshop number... 7 or 5. Let's try 5. Okay, okay, it was a workshop. Well, okay. It's a workshop question. We don't have written solutions for workshop questions, so let's go ahead and do this then. All right. Can you see the car's locked? Okay. All right, so what we want to start by doing is identifying all of the input sources in the system and all of the outputs in the system. So, okay, so we have 2-button remote control. We have 2 buttons. That's a good start. There are 2 buttons on the remote labeled unlock and lock. Albeit, this is legitimately the same question as the one in the workshop. That's fair. It's a good time to use previous exam questions in workshops. So, okay, so we have unlock and lock as 2 buttons and a source of timing signals that ticks 10 times per second. Now, it's a good idea to go ahead and make sure that you've read the entire question before you conclude that there are only 3 sources of event in this system. I can tell you that this system only has 3 sources of event. We've identified them already. So we have an unlock button